Following video is on constant velocity problems. If I have a particle P that is traveling with these parametric equations here, where time is greater than or equal to 0. The reason why time is greater than or equal to 0 is because we don't know what's happening to this object before this, before time 0. When we have time -1 or -2, maybe there's a turn, or maybe the object is stopped. But we just know what happens to the object after time equals 0. So we know that the distance is in centimeters and time is in seconds. So it says find the initial position of P. So the first thing I'm going to do is I'm going to rewrite my parametric equations so that I have a vector equation. So I have 1, 2 plus t times 2, -5, 2, -5. So then what's my initial position? My initial position is going to be at 1, 2. Illustrate the initial part of the movement, of the motion of P, where t equals 0, 1, 2, and 3. So, well, we already know what happens when t equals 0. We've already identified that as our initial position when you plug in 0 for t. When you plug in 1 for t, I get 1 times 2, which is 2, plus 1 gives me 3. And then plug in 1 times -5 is -5. -5 plus 2 is going to give us -3. Plug in 2. 2 times 2 is 4. Plus 1 is 5. Plug in 2. 2 times -5 is going to give us -10. -10 plus 2 is going to give us -8. And the last one, plug in 3. 3 times 2 gives us 6. 6 plus 1 is 7. And 3 times -5 is going to give us -15. -15 plus 2 is going to give us -13. So if I want to illustrate this, well, when t equals 0, I'm at 1 over and 2 up. So t equals 0, I'm at this location here. When t equals 1 second, I'm at 1, 2, 3 over from the origin, and 1, 2, 3 down. So that would be t equals 1. And when t equals 2, that would be 3, 4, 5 over, and 3, 4, 5, 6, 7, 8 down. So here, this would be t equals 2 seconds. And then when t equals 3 seconds, that would be 5, 6, 7 over, and -8, 9, 10, 11, 12, 13. So we're looking at a point about right here. That would be t equals 3. So we're looking at, here's our trajectory of our object that goes through these points right here. We are moving in this downward to the right sort of direction, and the points at these particular identified times when t equals 0, 1, 2, and 3 are identified by these little dots here. It says find the velocity vector. My velocity vector in this case is the same as my direction vector, so that's going to be 2, -5. And then I want to find the speed. Well, the speed of the object does not have a direction. It just has a magnitude. If my velocity vector has a direction and magnitude, we just find the magnitude, so I have the square root of 2 squared plus -5 squared, which is going to give me the square root of 4 plus 25, or the square root of 25, square root of 29 centimeters per second. Centimeters per second. Number 2 says find the velocity vector of a boat initially at 2, 3, which travels with a velocity vector of 4, -5. The grid units are in kilometers and the time is in hours. So, well, let's just go ahead and draw our velocity, our vector equation as xy equals our initial point, which is 2, 3, plus t times 4, -5. Part B says locate the boat's position after 90 minutes. Well, if this equation is in hours, let's rewrite 90 minutes in hours, so that would be 1.5 hours. So if I want to find the position of the boat, I'm just going to plug in 1.5 into time here. So I get x equals 2 plus 1.5 times 4, and y equals 3 minus 5t, which is 1.5. And then, so that's going to give me a position of, well, 1.5 times 4, that's going to give me 6. 6 plus 2 is 8. And then negative 5 times 1.5 is going to give me negative 7.5. And negative 7.5 plus 3 is going to give us negative 4.5. How long will it take for the boat to reach this point of 5 negative, the point is 5 negative 0.75? Well, let's take that point and plug it into our vector equation. So I have 5 negative 0.75, and that equals 2, 3 plus t times 4 negative 5. Now I have two parametric equations. I have 5 equals 2 plus 4t, and I also have negative 0.75 equals 3 minus 5t. Now, both of these will give me the same value for t, and because the first one doesn't have a decimal, I'm going to choose to use this first one and solve for t just because it's easier. So I have 5 equals 2 plus 4t, subtract 2 from both sides, that gives me 3 equals 4t, divide by 4, that gives me that t equals 3/4 of an hour, or 45 minutes. Part 3. Part 3 I'm going to let you do on your own. I'm going to move on to part 4. If you want to pause and do this particular problem on your own, you're welcome to do that. Number 4, well, there's 2 parts of 4. I'm going to do one of these. So it says, each of the following vector equations represents the path of a moving object. This is actually not a vector equation. These are parametric equations. It says t is measured in seconds, and t is greater than or equal to 0. Distances are measured in meters. So for all of these, I want to find the initial position. I want to find the velocity vector. I also want to find the speed of the object. So I'm going to do B, and the only reason I'm doing B is because I think B is more difficult. Then you can do A on your own. So the first thing I'm going to do is I'm going to rewrite these parametric equations into a vector equation. So that gives me x, y, z equals 3, 0, 4, plus t times my direction vector of 2, negative 1, and negative 2. So, well, what is the initial position? The initial position is at 3, 0, 4. My velocity vector is going to be 2, negative 1, negative 2. So 2, negative 1, negative 2. And then my speed, the speed is going to be just the magnitude of my velocity vector. So that's going to give me the square root of 2 squared plus negative 1 squared plus negative 2 squared. 2 squared, that's going to give me 4 plus 1 plus 4. That's going to give me 8, 9, so square root of 9, or 3 what? 3 meters per second. 3 meters per second. All right, so the next one, it says, find the velocity vector of a speedboat moving parallel to this particular vector of 4, negative 3 with a speed of 150 kilometers per hour. Well, let's find out what the speed is of this vector. The speed of this vector is going to be, well, the magnitude of the vector is going to give me the square root of 4 squared plus negative 3 squared, which is going to give me the square root of 16 plus 9, or the square root of 25, which is 5. The magnitude of this vector is 5, but I want the magnitude of the vector to be 150. So there's going to be some scalar in front of here that's going to give me then a speed of 150. So let's find out how many of these vectors I need in order to go 150 kilometers. Right now I'm going 5, so let's find out how many times 5 goes into 150, and that becomes what, 30. So my scalar then is going to be 30. 30 times this vector of 4, negative 3 is going to give me, now I have a vector going parallel to this vector with a magnitude of 150 kilometers per hour. So that would give me what? 120. 30 times negative 3 is going to give me negative 90. So there you go. You do B the same way. It looks like, though, that my parallel vector or my direction vector is 2, 1. So basically the same concept though. All right, moving on. I'm going to skip 6. This is what 6 looks like. If you want to pause the video, do it on your own. Number 7, I have 2 yachts. I have yacht A and I have yacht B. These are the equations are parametric equations. So the first thing I want to do is I want to rewrite both of these parametric equations as vector equations. So I have A equals 4, 5, and plus t times my direction vector of 1, negative 2, and the other direction vector is going to be 1, negative 8, plus t times 2, 1. And I want to find the initial position of each of the yachts. So A is at 4, 5, and B is at 1, negative 8. Find the velocity vector of each yacht. Well, the velocity vectors are my direction vectors here. So I have A is 1, negative 2, and B is 2, 1. Find the speed of each yacht. Find that the speed of each yacht is constant and state the speed. Let's just state the speed. So the speeds of these velocity vectors are going to be the magnitude. So I have the square root of 1 squared plus negative 2 squared, which is going to give me the square root of 1 plus 4, which is the square root of 5. This is A. Square root of 5, speed, again, this is going to be, well, let's look. It's the time is in hours and distance is in kilometers, so I have kilometers per hour. And then B is going to be, the speed of B is the square root of 2 squared plus 1 squared, which is 4 plus the square root of 4 plus 1, which is the square root of 5. So it looks like the speed of both of these yachts is the same. So these are the same for A and B. Part D, it says, verify algebraically that the path of the yachts are at right angles to each other. So if you recall, the dot product of U dot V, if it equals 0, then theta is 90 degrees. So let's find our direction vectors. Here's our direction vectors here, and we're going to do the dot product, which is the product of our x values, so 1 times 2, plus the product of our y values, which would be negative 2, 1, and this should equal 0. Well, 1 times 2 is 2, and then negative 2 times 1 is negative 2, and 2 minus 2 gives us 0, and 0 equals 0. So this is verifying algebraically that, again, that the direction vectors are perpendicular. I'm not going to do number 8. Here's what number 8 looks like if you want to pause the video. Here's the last part of 8. And then 9, I'll finish up 9 and then we'll be done with the video. It says, a helicopter at this particular location moves with constant velocity in a straight line. 10 minutes later, it is at this location here, and distances are in kilometers. So the first question is that it wants me to find the vector from A to B. Well, if you recall, you can find a vector if you're given coordinates. We just take head minus tail. So the head is B, so I have 3, 10, 2.5, and I'm going to subtract the tail, which is 6, 9, 3. That's going to give me negative 3, 1, and negative 0.5. Find the helicopter speed. Well, the helicopter speed is just going to be the magnitude, so I have the square root of negative 3 squared plus 1 squared plus negative 0.5 squared. Well, negative 3 squared is going to give me 9 plus 1 plus negative 0.5 squared is going to give me 0.25. So we're looking at the square root. If we add up all this, we have the square root of 10.25. 10.25, we're looking at speed, and this is going to be kilometers per 10 minutes. Now, if you would prefer, you can find out how many kilometers per minute just by dividing by 10. So throw that in your calculator. The square root of 10.25 divided by 10, that will give you kilometers per minute. Next one, determine the equation of a straight line path of the helicopter. So the equation then, let's just use a vector equation, is going to be our starting point of 693 plus t times our direction vector of -3, 1, -0.5, and that's going to be equal to x, y, z, right? I just put this in a different order, but it's the same concept. The helicopter is traveling directly towards its helipad, which has a z coordinates of 0. Find the total time taken for the helicopter to land. So we have this vector equation here, and we have, in fact, 3 parametric equations. We have x equals 6 minus 3t. We have y equals 9 plus t. And we have z equals 3 minus 0.5t. Now the only thing that really matters, because we're given that the z coordinates is 0, the only thing that really matters is this parametric equation here. So let's make z 0. So I have 0 equals 3 minus 0.5t. Subtract 3 from both sides, that gives me -3 equals -0.5t. Divide both sides by -0.5, and that's going to give me that t equals 6. Well, 6 what? So 6, if we go back to our original equation, we go back to part B, we see that we're looking at our speed in terms of per 10 minutes. 10 minutes is in my denominator, and time here of 6 something, that's a time, so I'm going to plug that in the denominator as well, so I get 6 times 10, which is 60. 60 minutes, or 1 hour. So there you go. Hope this was helpful, and have a wonderful day.